Hello friends, so today we're going to discuss about the different types of addressing that is used in the TCP IP. Okay, now let us discuss about the different types of addressing. So there are three levels of addressing that is used in the TCP IP model. The first is a physical addressing, second is a logical addressing, and third is port addressing. Now let us discuss about the TCP IP model. It is containing the 5 layers. The first is a physical layer, second is data link layer, third is network layer, fourth is transport layer, and fifth is a application layer. So basically the data link layer using the physical addressing, where the network layer uses a logical addressing. The transport layer uses a port addressing. Now let us discuss each addressing in detail. Now let us discuss about the physical address. The physical address is also known as a link address because this addressing is done by the data link layer. So this is also called as a link address. It is the address of the node as defined by its LAN or a WAN. Basically in the link layer, your device is connected by Ethernet cable. So this is the address of the node, particular node that is defined by the LAN cable or a WAN. It is included in frame used by the data link layer. So basically the data link layer convert the data into the frames, and in each frame it will assign the physical address of source and as well as destination. It is a lowest level address. This addressing is done at the second level, that is a data link layer. So this is called as a lowest level address. The Ethernet use 6 bytes physical address that is imprinted on the network interface card. Basically the physical address we can find it on the network interface card, which is imprinted. We can't change it. Now let us take an example. This is the address which is denoting the physical address. Can you see it is a 6 byte physical address? Now let us consider this diagram. Over here there are 4 devices are connected. Okay, now let us consider this is a frame. It is showing this is a one frame. So it is showing the destination as well as a source address. So what is my source address? Source address is a 10. So this user is acting as a sender. And where the 87 is my destination address. So 87, this PC is acting as a receiver. So this frame is sent by this sender to this receiver. So whenever data is converted into the frame, each frame containing the destination address as well as a source address. Now let us discuss the next type, that is a logical addressing. A logical address are necessary for the universal communication and that are independent on underlying physical network. Basically with the help of physical address, we can send the data to the host which are connected to the same network. Now let us imagine my senders and receivers at the 2 different network layer. So at the 2 different network layer, we have to go with the another addressing method that is called as a logical addressing. The IP address, basically in this case, we're going to assign the IP address. So the IP address provides the unique identity to each host. So at the network layer, we deal with the IP address because we connect the 2 different networks. A physical address are not adequate in an inter-network environment where the different network can have the different address format. Basically, whenever we are connecting the 2 different networks, so in that case, we cannot use a physical address because in the physical address goes on changing if you move from one network to the another network. So in that case, you need the different addressing method. A universal addressing system is needed in which each host can be identified uniquely regardless of underlying physical network. So it is a possibility that the physical network can be changed, and along with that, your physical address is going to change. So when you are connecting the 2 different network, you need the addressing which identify each host. So IP address will provide the unique identity to each user. The logical address are designed for this purpose. A logical address in the internet is currently 32-bit address, and that can uniquely define the host connected to internet. So basically the IP address, it is of 32 bits and it is a unique address. Each user will have the unique IP address. The two hosts cannot have the identical IP address. No two public address and visible host on the internet can have the same IP address. So just now we discussed the two hosts cannot have the same IP address. The physical address change hop to hop, but logical address will remain the same. So why we come up with the logical addressing? Because as you change the network, it is a possibility that your physical address goes on changing, where the IP address will remain same throughout the network. Now let us discuss this example. Now here, this is a one network. This is a one network, this is another network, and this is a third network. Now let us discuss here the source. This is my source address and this is my destination address. So here this is showing source and destination address, that is 20 and the 10. Now this frame that is passed from the network 1, and when it reached to the network 2, can you see my source and destination address has been changed? Initially it was 20 and 10, but when it reached to the second network, the destination address has been changed. It become 33 and 99. So as you know, the physical address goes on changing when you switch the network. Where now let us consider the next network. Whenever this frame is come to the network 3, and now their destination physical address also changed. Now it become 95 and 65. Initially it was 33, 99. Now when it entered to the third network, my physical address has been changed, that is it become 95 and 65. So can you see, if we use a physical address, then we cannot send the data, because physical addresses goes on changing when you change the network. Where now let us talk about the logical address. Now let us talk about the logical addressing. Now A and P. In the logical address, the A and P are my source and destination address. Now see, this frame is moved to the network 2. Whenever it is on the network 1, my addresses are, the source address is A and my destination address was P. Now when it moved to the network 2, still it is showing A and P. And now this frame, when it moved to the network 3, still my destination address, it is showing A and P. So with the help of logical address, you can communicate with the two computers which are connected to the two different networks. The physical address goes on changing, where the logical address will remain same. So for the two computers which are connected to the different networks, for that we will go for the logical addressing instead of that of physical addressing. So where here my A is a source and P is my destination. So with the help of logical addressing, the A is able to send the data to the destination P. Now let us discuss about the logical address in detail. The logical address are designed for the purpose. Now let us discuss about the next type of addressing, that is a port address. The IP address and the physical address are necessary for a quantity of a data to travel from source to destination. So with the help of IP address, your data will reach from source to the destination. However, arrival at the destination host is not the final objective of data communication. The computer are the devices that can run the multiple processes at the same time. So our requirement is not only to reach the packet from one computer to the another computer. What is our final aim? That my packet should reach to the appropriate process On one computer, it is possible that more than two processes are going on. So your packet should be reached to that specific process, and that is done by the port addressing. The computer are the device that can run the multiple process at the same time. For example, on the laptop, you may are accessing your Facebook, you may accessing your mail at the same time. So whatever the packet should reach to the Gmail, it should go to that process. Whatever the information that is related to the Facebook, it should go to the Facebook process. The end objective of the internet communication is a process communication with the another process. So what is our end objective? That is, the process of the sender should communicate to the process of the receiver. For example, a computer A can communicate with the computer C using a telnet. At the same time, the computer A communicate with the computer B by using the FTP protocol. For this process to receive the data simultaneously, we need a method to label the different process. So what the example we took, now let us consider there is a computer. Over there, the two processes are going on, or the two processes are communicating. One process is communicating with the FTP protocol and the second process is using the telnet protocol. So what is my requirement? That the the process of first should communicate with the second process. The telnet of the first process should be communicate with the telnet of the other process. The FTP protocol of the first process should be communicate with the FTP protocol of the second computer. So process to process communication is very important. In other words, they need an address. In the TCP/IP architecture, the label assigned to the process is called as a port address. So each process we are going to assign the different address. So that address is called it as port address. A port address in TCP/IP is a 16-bit in the length. Basically, it is a 16-bit in length. Example, the port address of 16-bit address represented by the 1 decibel number, that is 753. Now see here, this is my sender and this is my receiver. In the sender, the three processes are going on, that is A, B, C. Here in the receiver, there are two processes going on. Now A process want to communicate with the J process of the receiver. So process to process communication is possible because of port addressing. So here the application layer, transport layer will assign the port address. The network layer assign the logical address. Data link layer assign the physical address. Now let us discuss about the port number. So basically the port numbers are divided into the three categories. The first is well-known port. The second category is register port, and the third category is dynamic port. So between 0 to 124 ports are called as well-known ports, where 1024 to 49,150 ports are considered as registered port, and the remaining called as a dynamic port. So first are the well-known ports. The ports ranging from 0 to 123 are assigned and controlled by the CNN. Now let us consider the example of well-known port. Now HTTP uses the port number 80. HTTPS uses the port number 443. FTP protocol use the port number 20 and 21. DNS use port number 53. SMTP use a port number 25. POP3 use a port number 110. Then Telnet use a port number 23, where SSH use the port number 22. These are the example of well-known ports. Now let us discuss about the next category, that is a registered port. The port ranging from 1024 to 49,151 are not assigned or controlled by this committee. These ports are just registered to this CNN. They are not going to manage them. The next category is a dynamic port. The port ranging from 49,152 to 65,535, they are neither controlled or nor registered. They are just used as a temporary port. Thank you for watching this video. Stay tuned with Ekeeda. Subscribe Ekeeda.